Hi everyone, in this video I'm going to go over solving linear equations using both substitution and elimination. Thank you, Anna, for this comment here. So what we are going to do in this video is go over exactly all these things here. I've also added a small portion on how we can use graphing to solve equations. Okay, before we dive into the actual process of solving them, I do want to take a minute and just explain what these are and why they work. So when we're looking at a linear equation, what we're saying is we have a straight line, and that equation gives us the slope and the y-intercept to help us graph it. When we get that straight line as a graph, we can then graph another one with our systems of equation, and the two are going to intersect. So when they intersect, that actually is our solution. So it's where the 2 points kind of intersect, and that gives us the solution of the equation. So what I'm going to do is, using these examples here, I'm going to solve this graphically using substitution and elimination. And this way you can get why and how everything works. So looking at my equation, the first thing I'm going to do is rearrange it into what's called slope-intercept form. So this is our y equals mx plus b format. And the reason I might want to do that is if I'm graphing this by hand, this tells me my slope and my y-intercept. Using that, I can actually graph it pretty well, get the two straight lines, and again, where they cross each other, that's going to be the solution. So let's rearrange this, and I do want you to pay close attention to this, because one of the things that I notice with grade 10s is it's not quite the math that messes us up. It's actually the stuff from grade 7 or 8 that we didn't learn very well, and now we don't know how to apply it to this. So let's take a look here. We want to get everything in terms of y. That means I want to isolate the variable y and get y alone. So in order to do that, I need to move everything on this side of the equation to this side. So right now this is being multiplied by 3, so I'm going to leave that alone, but I'm going to move my x to the opposite side. And the way I do that is add a negative x to both sides. Now, if you've seen my other videos with algebra, I'm always kind of annoying about this. I'm always like, please rewrite everything. And this way, you're not gonna make any mistakes. So what we did here is, by adding a negative x to both sides, I was able to cancel out this and then bring my negative x to the right. Now I am one step closer to getting y alone. Okay, so looking at this, let's see what's going on. We're saying 3 times y equals all of this. Well, okay, that means I need to divide both sides by 3 to get y alone. So y is equal to 9 minus x over 3. So that is the equation rearranged for the first one. Now let's do the second one. Okay, so let's look at our second equation. So just like the last time, we want to isolate it for y. So what I noticed here is we've got a 4x on this side. And again, I want to bring it over to the other side. So the opposite of adding 4x is minusing 4x from both sides. And then again, we're going to go ahead and rewrite everything. Okay. Now, this one looks like it's almost done, but that negative y is not something we need. So what we want to do is move the negative over to the other side. The way I'm going to do that is divide it by a -1. And that is a long way of saying, in order to move the negative to the other side, all we really have to do is flip the signs of everything that's in here. So when I do that, I'm going to get y is equal to 4x. I'm just bringing over the 4x to the other side, or I'm just changing the order of the 4x, minus 10. So I didn't do anything. All I did was flip the signs. So this one was positive, it became negative. This one was negative, it became positive. And just to kind of stick with convention, when we think of the y equals mx plus b, I just put the 4x there. Now, most teachers are pretty forgiving if you kept the 4x there on the left. That doesn't matter. So why did I do all of this? What's the point in this? So the reason I did this is we can get our equation, like I said, into slope-intercept form. So now that we have our slope, we can use that to figure out our rise over run of the graph. And we also have our y-intercept. So we know where it's gonna hit on that y-intercept of the graph. Now, I'm not gonna graph it by hand, and I'm sure you guys are probably the same. You know that you can punch this into your calculator. I'm gonna do the same here. What I'm going to do is actually use this calculator here called Desmos. So I'll leave a link in the description there for you, but you can see I've typed in both my equations and we have our graph. And like I said last time, it's two linear equations and we can see where they cross. So let's go ahead and tap that one. And there is our solution. So our solution using a graph tells us that the two lines intersect each other at 3 and 2. So that means our solution is 3 and 2. Now, if everything is done correct, we're gonna solve it now using substitution, and it should be the exact same answer. Okay, let's solve this using substitution. Now, with this method, I do want to use a little bit of common sense or think about what's happening here. So we have two equations, and what we want to do is we want to rearrange one of them so it fits inside one of the equations. Once it fits, so we're going to be substituting it in, putting it in place of another, then we can solve for one of the values. So what I know is we've already actually rearranged the second equation in terms of y. So that's cool. I'm going to go back to my original equation of the first one. So I'm just copying it from what's up here. So the original is x plus 3y equals 9. And my rearranged equation, I just brought that down here. That's the second equation, and that's this equation. So what I'm trying to say is that whatever version of the equation you use, it still means the same thing. So now that I have it rearranged, what we're going to do is we're going to say, well, okay, wherever there is a y value, we're going to substitute this portion here. So we know what substitution is, right? You know what it means when you get a substitute as a teacher, right? You're having another teacher for the day take your teacher's place, right? Same thing is happening here. We're having another equation take the place of y. The reason for that is because we know that y is actually equal to this, okay? And if the two equations cross each other, they're gonna have a point where one equals the other. So now what I'm gonna do is, wherever I see this y value, I'm gonna pop in this here. So that's gonna look something like this. Okay, so I hope that this looks familiar because what we can do now is just solve for x. So I'm gonna walk you through the algebra because like I said, sometimes this gets a little confusing for people. So what I did is I gave this equation here a little bracket indicating that this was replaced by this. So the whole thing we know is being multiplied by 3. So I'm going to go ahead and rainbow that in. And then like I said last time, we are going to rewrite everything. So x plus 12x minus 30 equals 9. And then as we go through it, I can see I've got an x here and an x here. We can combine those. So we're going to use our like terms. 1x plus 12x is going to give us 13x minus 30 equals 9. Okay, again, we want to get x alone. So I'm going to add a positive 30 to both sides. That's going to give me 13x is equal to 39. Now we know that x is being multiplied by 13, so I have to do the opposite of multiplying by 13. That's going to be divide by 13. That's going to cancel out the 13s, leaving me with x alone. And it also tells me that x is equal to 39 over 13. If you don't know what that is actually 3. So what we're saying is when we pop in this equation, and we know that y equals to that equation, the x value is going to be 3. And we actually know that that's true. We did that in the previous one where we said, okay, when we solve it using a graph, they cross each other at x3. So that would be like right somewhere there. Okay, so now this is honestly kind of the easier part here. Because we know what x equals, we can put it back into one of the equations to figure out y. And this is where, again, we can kind of use a little bit of like common sense, make your life easier. Look at the equation and see which one is actually easier to solve. So for me, honestly, this one looks pretty easy to solve because we are looking at what happens when y equals something. So I'm going to rewrite the equation, and instead of the x value, I'm going to pop in the 3 and then minus 10. So I'm just copying this out, but that x value, we now know what it is, so I've put that back in, substitute it back in, if you will. So that's going to be y is equal to 12 minus 10. Well, what's 12 minus 10? That means y equals 2. And let's look at our graph. Yeah, we know that that's our solution. So our solution for this, just as we found out using the graph, is x equals 3 and y equals 2. All right, let's look at elimination. So what I've done here is this workbook, it does go through elimination, but for the purpose of this video, I'm going to use the same equations, proving that we can get the same answer no matter what method we use. So what I did is I actually just copied down the original equations and I wrote them out like this. So I'm going to push the workbook aside and let's take a look at our equations here. So the first thing you want to do is you want to stack the equation. This is no different than when you were younger and you had to stack the numbers by the ones, the tens, and the hundreds. So what I mean by that is we want to make sure we've got our numbers stacked on one side with the equal sign, our y's, letter y's over one another, and then our x's together. I almost said exorcist. I know math is scary, but I don't think it's that scary. So what I want to do now is I want to find a way to eliminate one of the letters. Okay, so I have to do something to one or sometimes both of the equations that if I were to add those equations up, either x or the y's would cancel out. Okay, so we kind of have to use a little bit of common sense and thinking here with this. So the first thing that I actually notice is that this is already a negative y. And we know every time I have a negative and a positive and I add them together, they're going to cancel out. The only thing is we have 1y here and 3y's here. So that means I need to do something to this equation so that it becomes 3y, and therefore once I add it together, this will cross off, leaving me with an idea of what x can equal. Now I do want to take a moment here and say, you don't have to eliminate the y's. If you wanted to eliminate x by multiplying this by 4, totally fine. So again, that's where it kind of becomes tricky when you're learning it, but just use your best judgment, right? And you know that you can always check your answers using the Desmos graph, using your graphing calculator, substituting your numbers back in, multiple ways to always get this right. It just takes a bit of time. Sorry, okay, let's go back into here. So I'm gonna do what I said I was going to do. So what this means is I want to multiply the second equation by 3. And the reason I want to do that is that both of these will become 3. And when I add them together, the y's will be eliminated, right? So when I do this, again, as I've said before, I'm going to make sure we rewrite everything. So when I multiply the second equation by 3, we do need to remember everything in the equation also gets multiplied by 3. So that leaves me with the following. Okay, so now we can add them together. So this is going to cancel because negative 3y and positive 3y make 0. So really they just make 0, they don't cancel. X plus 12x, so that's gonna get me to 13x is equal to 36. And this looks familiar, right? It looks like what we were doing last time. And then I can divide both sides by 13. And that tells me x will equal 3. Perfect. So now, again, we have our x value, and then I can plug it into one of my equations to get the y value. So this time, I'm actually just going to plug it into one of our equations that we had to start off with. Okay, so now let's plug in the x value. Now we can plug it into either one of these equations here. It doesn't matter. So whichever one you are comfortable. I look at it and I kind of say whichever one involves the less math. But let's plug it in. So we know x is 3. So 3 plus 3y equals 9. Well, we want to solve for y. We want to get y alone. So in order to do that right now, we have a 3 being added to that equation, or to that part of the equation. So I'm going to add a negative 3 to help isolate that y alone. And we've seen this before, but we'll do it with our numbers this time. So 9 minus 3 is going to be 6. So we're saying 3 times y equals 6. Let's divide both sides by 3. that means y is equal to 2. And so once again, we've got the same answer, 3, 2. All right, so I just want to take a minute and just remind you, unless if you're being asked to use a specific method when it comes to elimination or substitutions, both methods will work. The goal is to always make sure you're able to isolate for one of those variables or cancel out one of those variables. Okay, I really hope that helped. In the description below, I have a practice test, this workbook, and some videos that actually go over how to isolate for a variable. In the next video, I'm going to go over some application questions involving elimination and substitution. So until then, I'll see you all on the next one.